This is an Edexcel higher tier non-calculator practice paper. It's based on the topics that come up most often in non-calculator papers. But I have to say that topics will appear on the actual exam paper that are not included here, and they will probably be worth around 30 marks of the paper. So this shouldn't be your only revision. You should do as many past papers as possible to increase your coverage. The way this is going to work is for each question, there's going to be a similar question first, and then you can pause the video and try the question from the practice paper. There's a link to the paper in the description, and it's probably easier to print the paper out and work through it. Otherwise, you can do it on the screen, but for some questions where you need to draw on the paper, that won't be possible. Okay, let's get started. So question 1 says write 124 as a product of its prime factors. So I'm going to do this one, and then I'll pause the video, and then there was a similar one for you to try. So to write a number as a product of its prime factors, we need to write it as prime numbers multiplied together. So 124 I can break down into 2 times 62, where 2 is a prime number, 62 isn't, because it is 2 times 31. 31 is a prime number. It's not in any times table apart from the 1 times table and the 31 times table. So our answer is 2 times 2 times 31, or 2 squared times 31. Okay, one for you to try. So we're going to write 204 as a product of its prime factors. So it's 2 times 102. 2 is prime. 102 can be broken down again. So 2 times 51. 2 is prime. 51 isn't. It's in the 3 times table because its digits add up to a multiple of 3. 5 and 1 is 6. And it's 3 times 17. 17 is prime. So 204 can be written as 2 times 2 times 3 times 17, or 2 squared times 3 times 17. Question 2. We're multiplying fractions here. We could be asked to add fractions or take away fractions or divide fractions, but in this question we are multiplying fractions. To multiply fractions, we need to first make the fractions into top-heavy fractions. So I'm going to change these into top-heavy fractions. So 2 and 1/3. 2 is 6/3. 2 times 3 is 6. So 6/3 and another third is 7/3. 3 times 4 is 12. So 3 is 12 quarters. 12 quarters and 3 quarters make 15 quarters. To multiply fractions, we times the top and we times the bottom. But it can be easier to simplify before we times them. So as long as we divide top and bottom by the same number, we can simplify the fractions. So I can divide the top by 3 and the bottom by 3. So we have 7 times 5 on top, which is 35. 1 4 on the bottom, which is 4. So how many 4s go into 35? That's 8. 8 4s are 32. So we've got 3 left over. We've got 8 3/4. That's what we wanted to show. and one for you to try. So 1 2/3 times 3 1/5. So 1 times 3 is 3, plus 2 is 5. So 5/3. 3 5s are 15, plus 1 is 16, times 16/5. I'm going to simplify first, divide the top and the bottom by 5. So I've got 16, 1/16 is 16 on the top, 3 1s are 3, 16/3. How many 3's go into 16? So it goes in 5 times with 1 left over. So 5 1/3. Question 3. Kyria is 7 years older than Jay. Martha is twice as old as Kyria. The sum of their 3 ages is 77. We need to find the ratio of J to K to M. So I'm going to write an equation for this. I'm going to turn this information into algebra, into letters. So I'm going to call them K, J, and M. K is 7 years older than J. So K is 7 older than J, so K minus 7 will equal J. Martha is twice as old as K. M is 2 Ks. M is equal to 2 Ks. The sum of their ages is 77. So K and J and M added up make 77. And I can change J into K minus 7. I can change M into 2K. So I have an equation just in terms of K. So K plus K minus 7 plus 2K equals 77. So simplifying, I've got 4 Ks. Take away 7 is equal to 77. I want to solve for K, so I want to get K by itself. I'm going to get rid of minus 7 by doing the opposite of taking away 7, which is adding 7. So I add 7 to both sides. 4 Ks are 84. I then divide by 4. So K is 21. So K is 21. J is K minus 7. So 21 minus 7, which is 14. M is 2 Ks. 2 21s make 42. So I'm going to write the ratio of J to K to M. 14 to 21 to 42. And one for you to try. Abby is 9 years older than Ben. So A minus 9 is B. Charlotte is twice as old as Abby. So Charlotte is 2 A's. The sum of their ages is 67. We need to write the ratio of A to B to C this time. So A plus B plus C is 67. I'm going to change B into A minus 9. Change C into 2 A's. So I've got 4 A's minus 9 is 67. I want A by itself. So plus 9 to both sides. I then divide by 4. So you can always use a division technique. So 4 goes into 7 one time, with 3 left over. 4 goes into 36 9 times. So A is 19. B is A minus 9. So 19 minus 9, which is 10. And C is 2 A's, 2 19s, which is 38. So the ratio of A to B to C is 19 to 10 to 38. Question 4. A shop sells packs of black pens, packs of red pens, and packs of green pens. There are 2 pens in a pack for black pens, 5 pens in a pack for red pens, and 6 pens in a pack for green pens. On Monday, the ratio of packs of black pens sold to packs of red pens sold to packs of green pens sold is 7 to 3 to 4, and 212 pens were sold. Work out how many green pens were sold. So we've got the ratio for packs of pens sold. This isn't the ratio for pens. It's the ratio for packs. So to find the ratio for pens, we need to times by the number of pens in each pack. So for black to red to green, the ratio of pens sold. So for black, 7 packs, 2 in a pack, 7 times 2 is 14. For red, 3 packs, 5 in a pack, 3 5s are 15. And for green, 4 packs, 6 in a pack, 4 6s are 24. So that's the ratio of pens sold now. We've got the ratio of pens sold, and we know there's 212. So we can work out how many parts we've got. 14 and 15 and 24. 4, 5 and 4 make 13. 1, 1, 2 and 1 is 5. So 53 parts. And we've got 212 pens. So we're going to share the 212 pens between the 53 parts. How many 53s go into 212? And it is 4. 4 50s make 200. 4 3s make 12. So how many pens of each colour were sold? So times the ratio by 4. So we have 14 4s. 10 4s are 40. 4 4s are 16. So that's 56. 15 4s, 60, and 24 4s. So that is 96. So how many green pens were sold? 96 green pens. One for you to try. So pause the video and give it a go. So again, black pens, red pens, green pens. We've been given the ratio of packs sold, not the ratio of pens sold. So we need to work out the ratio of pens by doing the number of packs times the number of pens in a pack. So 5 8s are 40, 5 4s 20, and 2 3s 6. So there's 66 parts, and 264 pens were sold. So 264 over 66. We can half it to make it easier. Divide it by 11. So we've got 4. So each part is worth 4. So 4 40s are 160, 4 20s are 80, and 4 6s are 24. So how many green pens? 24 green pens. Question 5. ADC is a triangle, AED and ABC are straight lines. EB is parallel to DC. EBC is 148. ADC is 63. We need to work out EAB. So it's always the one in the middle, from E to A to B. That's this angle here. And we must give a reason for each stage of our working. So we've got parallel lines. And when we have a line that goes through parallel lines, we get the same angles with both. So if I extended this line and this line and this line, we would get the same 4 angles. So these 2 angles are the same, they're corresponding. These 2 angles are the same, they're corresponding. These 2 angles are corresponding. And these 2 angles are corresponding. The same angles are made through both parallel lines with the same straight line, and the ones that are equal, the ones that go together, are called corresponding angles. And corresponding angles are equal. So this green angle is 63 degrees. So AEB is 63 degrees. And the reason, we must give a reason, is that they are corresponding angles. We can also have co-interior angles, which add up to 180 degrees. So the black one and the green one here, they make a C shape along there, down there, and back along there. Those 2 inside there are co-interior. They add up to 180. And we can also have alternate angles, which make a Z shape. So these blue and green ones are called alternate angles. They're equal and they make a Z shape. But for this question, we only need corresponding angles. We can then use angles on a straight line, add up to 180 degrees. So ABE is 32 degrees because angles on a straight line add to 180 degrees. And then to find x, we can use angles in a triangle. So we have 63 and 32, which means we've got 95 so far. How many more do we need to get to 180? We need another 85. So EAB is 85 degrees because angles in a triangle add to 180 degrees. Okay, one for you to try. Give this one a go. So it's the same question. Remember, we need to give a reason for each stage of our working, otherwise we won't get all of the marks. So we need to say that AEB is 56 degrees because they are corresponding angles. ABE is 180 take away 123, which is 57 degrees, because angles on a straight line add to 180. And then we've got angles in a triangle, which add up to 180. 56 and 57 make 113. How many more to get to 180? Add 60 to get to 173, and then 7 more, so 67 degrees. So EAB is 67 degrees because they are angles in a triangle. Question 6. A car travels for 18 minutes at an average speed of 72 kilometers per hour. How far will the car travel in these 18 minutes? So you need to remember the formula. Speed is equal to distance divided by time. And if we need to work out the distance, how far it will travel, we need to times both sides by time, and we'll get distance is equal to speed times time. We've got 72 kilometers per hour, but we've got the time in minutes. We've got 18 minutes. So to do this calculation, I want to change 18 minutes into hours. So 18 minutes is 18/60ths of an hour. So I'm going to have 72 times 18/60ths, but I can simplify this fraction to make the calculation easier. So half top and bottom, 9/30ths, divide by 3, 3/10ths, and it's probably easiest to write it as a decimal, which is 0.3. So the distance is 72 times 0.3. To times by 0.3, I'm just going to times by 3 and then add decimal point back in afterwards. So 72 times 3, 3 2s are 6, 3 7s are 21. So it's 216, but I'm going to add the decimal point back in. One number after the decimal point in the question means I need one number after the decimal point in the answer. So 21.6 kilometers. Part B. David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? So we need to convert 72 kilometers per hour into meters per second and then compare that answer with 20. So 72 kilometers is 72,000 meters per hour. So if we can go 72,000 meters in an hour, we can divide that by 60 to work out how far we go in a minute. 72,000 divided by 60. So how many 6's go into 7,200? 6 goes into 7 once. 6 goes into 12 2 times. So it's 1,200 meters per minute. And then to work out how far we go in a second, divide by 60 again. So 1,200 divided by 60 is 120 over 6. 12 over 6 is 2. So 120 over 6 is 20. So that's 20 meters per second. So it's the same. 72 kilometers per hour is equal to 20 meters per second. So is David correct? No, because they are equal. Okay, one for you to try. So pause the video and give it a go. So we've got a car travels 42 minutes at an average speed of 90 kilometers per hour, and we're working out the distance. So speed is distance over time. So distance is speed times time. But again, we've got 90 kilometers per hour and 42 minutes. So 42 minutes is 42 sixtieths of an hour, which is 21 thirtieths, divided by 3 7/10, 0.7. So the distance is speed times time, 90 times 0.7. That's the same as 9 times 7, which is 63 kilometers. Part B. David says 90 kilometers per hour is faster than 25 meters per second. Is he correct? So 90 kilometers is 90,000 meters. Divide by 60 to work out how far we go in a minute. 90,000 divided by 60 is the same as 9,000 over 6, which is the same as 4,500 over 3. 45 over 3 is 15, so it's 1,500 meters per minute. To change it to seconds, divide by 60 again. So 1,500 over 60 is the same as 150 over 6, which is 75 over 3, which is 25. So 25 meters per second. So again, they are equal. So no, he's not correct, because 90 kilometers per hour is 25 meters per second. Question 7. So we've got a cumulative frequency question. The table shows some information about the profit made each day at a cricket club on 100 days. So here is our table of information. Part A says complete the cumulative frequency table. When we have cumulative frequency, we add up as we go. So the 0 to 50 box is the same as the 0 to 50 box in our first table. So up to 50, there are 10 days. From 0 to 100, we want the first box and the second box added together. So 10 and 15 make 25. 0 to 150, so everything up to 150 means we add on the next box. Add on 25 makes 50. Up to 200 means add on the next box. 50 and 30 is 80. For up to 250, add on the next one. So 85. And then for everything up to 300, add on another 15 days, which gets to 100. Part B says draw a cumulative frequency graph. For a cumulative frequency graph, we plot the top point against the cumulative frequency. It's not the midpoint. If it's a frequency polygon, which you might get, that's plotting the midpoint against the frequency. But for cumulative frequency, it's top point against frequency. 10 days are up to £50. So £50, 10 days. £100, 25. So halfway between 20 and 30. 150 against 50. 280. 250, 85. And 300, 100. You can join them up with a curve or straight lines. I'm going to use straight lines. And that is my cumulative frequency graph. Use your graph to find an estimate for the number of days the profit was less than £125. So I'm going to go to £125, which would be halfway between 100 and 150. I'm going to draw a line up to the graph and then along, and I'm going to read off my answer. So that's 30, 32, 34, 36, something around 36. So that's 36 days. D says use your graph to find an estimate for the interquartile range. So we've got 100 days. If we wanted the median, we'd go from the 50th day down and read off the profit. So we'd say the median is 150. For quarters, we split the data into quarters. So the lower quartile is at 25. So 25 along to the graph and down, which gives us 100. So the lower quartile is 100. For the upper quartile, we go to 75 along to our graph and down. So that looks like 180, 185. No, 190 or 195, sorry. So I'll call that 195. 195. So the interquartile range is the difference between the lower quartile and the upper quartile. So the upper quartile take away the lower quartile is 95. There'll be a range of acceptable answers for that. So as long as you've gone from 25 and 75 and read off your graph, you should be okay. Okay, one for you to try. So pause the video and give it a go. So again, part A, we're completing the cumulative frequency table. We're adding up as we go along. So the first one's 8. Then we add on the next one. 8 and 12 make 20. Add on the next one. 20 and 20 make 40. Add on the next one. 40 and 30 make 70. Add on 19. And then add on 11. So again, we've got 100 days. Draw the cumulative frequency graph. So again, plot the top point against cumulative frequency. Don't plot the midpoint, because it's everything up to 50, everything up to 100. So 58, 120, 150, 40, 270, 250 against 89, and 300, 100. So again, I'm going to join them up with straight lines. You can use a curve or straight lines. And part C says use your graph to find an estimate for the number of days the profit was less than 160. So we're going to go to 160. Up to our graph. And then along. and read off the number of days. So that's 40, 42, 44, 46. So 46 days. And again, working out the interquartile range. So we're going to split the data into quarters. So the 25th day is around there. So I'm going to say that's 110, 115. The 75th day is there, which looks like 215. So I've got 215, take away 115, which is 100. And again, there will be a range of acceptable answers for that question. Question 8. Part A, write down the value of 7 to the power of 0. So anything to the power of 0 will be 1. Part B, find the value of 3 times 3 to the power of 6 times 3 to the power of negative 6. So 3 is the same as 3 to the power of 1. And when we multiply indices, we add the powers. So 1 and 6 make 7. Minus 6 is 1. So we've got 3 to the power of 1, which is just 3. Part C, find the value of 2 to the power of negative 4. So when we have a negative in the power, it means flip it over. It's the reciprocal. So it's the reciprocal, or 1 over 2 to the power of 4. 2 to the power of 4 means 2 times 2 times 2 times 2, and that is 16. So it's 1/16. And part D, find the value of 27 to the power of a third. The power of a third means the cube root. The cube root of 27. What number times itself and times itself again makes 27, and that is 3. Okay, some for you to try. So part A, the value of 27 to the power of 0, that's 1. 3 times 3 to the power of 4 times 3 to the power of negative 5. So 3 to the power of 1 times 3 to the power of 4 is 3 to the power of 5 times 3 to the power of negative 5. 5 plus minus 5 is 0. So it's 3 to the power of 0, which is 1. Part C, 5 to the power of negative 3. That's the same as 1 over 5 cubed. A negative power means the reciprocal. Flip it over. 5 cubed is 125. And part D, find the value of 64 to the power of a third. The power of a third means cube root, and it's 4. 4 times 4 times 4 makes 64. Question 9. Given that A over B is 2/5 and B over C is 3/4, find the ratio of A to B to C. So when we have a fraction, we can turn it into a ratio. So we can say A to B, the ratio of A to B is 2 to 5. So if we double top and bottom, we'll have 4 and 10. If we times them by 10, we'll have 20 and 50. They're always in the ratio 2 to 5. And we can do the same for B to C. That's 3 to 4. To make them one ratio, we need to make the B's the same. And we can do that by timesing our first ratio by 3 and our second ratio by 5. Then both the B's will be 15. So times this by 3 will be 6 to 15. Timesing our second ratio by 5 makes it 15 to 20. Now we can make them one ratio. The b's the same, so we can just write it as 6 to 15 to 20. Okay, one for you to try. Pause the video and give it a go. So we have A to B is 3 to 4. B to C is 3 to 7. We need to make the b's the same. So times the first ratio by 3 and the second one by 4. So we've got 9 to 12 and 12 to 28. Now we can just write them together. So it's 9 to 12 to 28. Question 10. Express 0.1 and then 17 recurring. So that means 0.1171717 and so on as a fraction. You must show all your working. So I'm going to call 0.117. I'm going to call that x. Now to change a recurring decimal into a fraction, we need two things that end in the recurring bit so we can take them away. So if I times this by 10, I'll get 1.17 recurring. That's 10 x's. I need something else that ends in 17 recurring. So if I times the original one by 1,000, I'll have 117.17 recurring, and that's 1,000 lots of x. Now I can get rid of the recurring bit by taking these away. Do the bottom one, take away the top one. So 1,000 x's, take away 10 x's, is 990 of them. And 117 point something, take away 1 point, the same something, is the same as 117 take away 1, which is 116. So I want x by itself, divide both sides by 990. So I've got 116 over 990. We don't have to simplify it, we aren't asked to, so I'm going to leave it as it is. And one for you to try. So express 0.265 recurring as a fraction. So I'm going to call 0.265 x times by 10 for 10x. I need something else that ends in 65656565. And again, that's 1,000 of them. 1,000 x's. I can get rid of the recurring bit by taking them away. It's 1,000. So 1,000 take away 10 is 990. 265 point something take away 2 point something is 263. And then divide both sides by 990. So we've got 263 over 990. Question 11. The diagram shows a solid shape. The shape is a cone on top of a hemisphere. So if we're working out the volume or surface area of cones and hemispheres, we're going to be given the formulas. So here we're given the volume of a cone and the volume of a sphere. So for a hemisphere, we just need to half that formula. So for a hemisphere, it's not 4/3 pi r cubed, it's 2/3 pi r cubed. So the height of the cone is 10, the diameter is 6, so that means the radius is 3 centimeters. The total volume of the shape is k pi centimeters cubed, where k is an integer, a whole number. Work out the value of k. So we need to work out the volume of this total shape. So the volume of the total shape is the volume of the cone, which is 1/3 pi r squared, so 3 squared times h, which is 10, plus the volume of the hemisphere, which is 2/3 pi times the radius cubed. So we just need to simplify this, and it should give us something in the form k pi. So 3 squared is 9, and 3 cubed is 27. 1/3 times 9 is like 1/3 of 9. Times means of. 1/3 of 9 is 3. 3 tens are 30. So we've got 30 pi plus 2/3 of 27. 1/3 of 27 is 9. 2/3 must be 18. So we've got 30 pi and 18 pi, which is 48 pi centimeters cubed. So k is 48. Okay, one for you to try. So give this one a go. So again, we've got the same question. We're working out the total volume. So again, for a hemisphere, we just need to half the volume of the whole sphere. Again, the radius is 3, and the total volume is just the volume of the cone plus the volume of the hemisphere. So the volume is 1/3 of pi times 3 squared times 12 this time, plus 2/3 of pi times 3 cubed. 3 squared is 9, and 3 cubed is 27. A third of 9 is 3. 3 12s are 36. So we've got 36 pi, and 1/3 of 27 is 9, so 2/3 must be 18. So 36 and 18 make 54. So it's k is 54. Question 12. So we've got a conditional probability question. We can draw a probability tree. There are 9 counters in the bag. We've got 7 greens. 1, 2, 3, 4, 5, 6, 7, and 2 blues. We're going to take 2 counters from the bag at random, and we need the probability that we're going to get 1 of each color. So we can draw a tree. So first pick and second pick. So for the first pick, we can get green or blue. And for the second pick, again, green or blue. The probability of getting a green for the first pick is 7 out of 9. There are 7 green out of 9 in total. If we pick a green for our first pick, there's 1 less green. So what's the probability of getting a green now? It's 6 out of 8. And if that green's gone, the probability of getting a blue is 2/8. If we get a blue first time, the probability of a blue, the first pick, is 2/9. 2 out of 9 are blue. If I take a blue out, the probability of getting a green is 7/8. And the probability of getting a blue is 1/8. So what's the probability of getting one of each color? So we can get green blue or blue green. And when we go across these branches, we times. The probability of green and blue is going to be 7/9 times 2/8. And that is the same as 14 out of 72. And for blue-green, 2/9 times 7/8 is again 14 out of 72. So probability of getting one of each color, we add these two together, 14 out of 72 plus another 14 out of 72 is 28 out of 72. We don't have to simplify our fraction. We're not asked to. That is absolutely fine for our answer. 28 out of 72. Okay, one for you to try. So give this one a go. So we can get green or blue for our first pick and green or blue for our second pick. So green or blue, green or blue, green or blue. So the chance of getting a green for the first pick is 5/8. Blue for the first pick is 3/8. If we take a green out, there are 4 greens left out of 7 in total and 3 blues out of 7. If we took a blue out, there'd be 2 blues left out of 7 and 5/7 green. Again, one of each color, so it can be green, blue. So 5/8 times 3/7. 5 3s are 15. 8 7s are 56. And blue, green. 3 5s are 15. 8 7s are 56. So 15 out of 56 plus another 15 out of 56 is 30 out of 56. So the chance of getting one of each color is 30 out of 56. Question 13. Prove that the square of an odd number is always one more than a multiple of 4. So we can write an odd number as an even number, which is the 2 times table. An even number plus 1. One more than the 2 times table is odd. And we want to square it and then show it's one more than a multiple of 4. So 2n plus 1 squared means 2n plus 1 times 2n plus 1. 2n times 2n is 4n squared. 2n times 1 is 2n. 1 2n is 2n. And 1 1 is 1. So we've got 4n squared plus 4n plus 1. So it needs to be one more than a multiple of 4. So I can factorize 4 out of these first 2 terms. So I've got 4 times n squared plus n, and then plus 1 on the end. So this is a multiple of 4. If you can factorize 4 out of it, it must be a multiple of 4. It's 4 times something. So it's a multiple of 4, and then plus 1. So it's one more. One more than a multiple of 4. Okay, one for you to try. So pause the video and try this. Prove that the sum of the squares of 2 consecutive odd numbers is always 2 more than a multiple of 8. So the sum of the squares of 2 consecutive odd numbers. So if we have an odd number as 2n plus 1, the next odd number, so consecutive means next to each other, the next odd number is always 2 more than the previous one. Odd numbers go up by 2 each time. So the next odd number must be 2n plus 3. And it's the sum, which means add, of the squares squared. So we're going to square them, add them together, and then show it's 2 more than a multiple of 8. So I've got 2n plus 1 times 2n plus 1 plus 2n plus 3 times 2n plus 3. I'm going to keep these brackets here. It's not really relevant for this question, but if you have a minus between them, it becomes very important to keep these brackets, because if this was a minus, we'd be taking away all of this bracket, not just the first term. So 2n times 2n is 4n squared. 2n times 1 is 2n. 1 times 2n is 2n. 1 is 1. 2n times 2n is 4n squared. 2n times 3 is 6n. 3 times 2n is 6n. And 3 3s are 9. So we have 4n squared plus 4n plus 1 plus 4n squared plus 12n plus 9. And we can just add these together. 4n squared and 4n squared makes 8n squared. 4n and 12n, that's 16n. And 1 and 9 is 10. So I've got to prove it's 2 more than a multiple of 8. And I can change 10 into 8 plus 2. So I've got a multiple of 8 and 2 more. So I can factorize 8 out of this. And then I've got 2 more. So I've got 2 more than a multiple of 8. That's a multiple of 8. And that is 2 more. Question 14. Show that 8 plus square root 12 over 5 plus square root 3 can be written in the form a plus root 3 over b, where a and b are integers, whole numbers. So the first thing I'm going to do is I'm going to simplify square root 12. So square root 12 is the same as square root 4 times square root 3. Square root 4 is 2, so that's the same as 2 root 3s. So I'm going to have 8 plus 2 root 3s over 5 plus square root 3. The next step is to rationalize the denominator. So that means get rid of the surd from the denominator. And to get rid of the root 3, I'm going to multiply by 5 minus square root 3. So when we have 2 terms in the denominator, we times by the same thing, but we change the sign. So if it's a minus, we change it to a plus. If it's a plus, we change it to a minus. And when we expand these brackets, that will get rid of the square root 3. And we're going to do that now. So that's times the top and times the bottom. 8 times 5 is 40. 8 times negative root 3 is negative 8 root 3. 2 root 3 times 5 is 10 root 3s. And 2 root 3 times negative root 3, a positive times a negative is negative. 2 root 3 times root 3. So root 3 times root 3 is just 3. So we've got 2 3s, which are 6. And on the bottom, 5 5s are 25. 5 times a negative root 3 is minus 5 root 3. Root 3 times 5 is 5 root 3. That's why it gets rid of the root 3's, because we've got a plus and a minus, which adds up to 0. And root 3 times negative root 3 is 3. So collecting these terms together, the like terms, 40 take away 6 on top is 34. Minus 8 root 3's plus 10 root 3's is 2 root 3's. And we've got 25 take away 3 on the bottom, which is 22. It's not quite in the form we want. We just want 1 root 3 on the top. But all we've got to do is half the top and half the bottom. And that's our answer. Okay, one for you to try. So pause the video and give it a go. So this time we've got 8 plus root 18 over 3 plus root 2. So I'm going to change square root 18. Square root 18 can be simplified. It's got a square number in it. It's got a 9 in it. So it's root 9 root 2, which is 3 root 2. So I can change the question to 8 plus 3 root 2 over 3 plus root 2. To get rid of the surd from the denominator, I'm going to multiply by 3 minus root 2. So whatever I multiply the bottom by, I multiply the top by the same thing. And now I just expand the brackets. 8 3's are 24. Positive times a negative is negative. 8 root 2's are 8 root 2. 3 root 2's times 3, that's 9 root 2's. A positive times a negative is negative. Root 2 times root 2 is 2. 3 times 2 is 6. In the bottom, 3 3's are 9. 3 times negative root 2 is minus 3 root 2. 3 root 2's are 3 root 2. Positive times a negative is negative. And root 2 squared is 2. So we have 18 plus square root 2 on top and 7 on the bottom. So that is our answer. Question 15. F and g are functions such that f of x is 12 over square root x and g of x is 3 times 2x plus 1. Part A says find g of 5. So that means substitute 5 into our g function. So wherever it says x, change it into 5. So g of 5 is 3 times 2 5's plus 1. 2 5's are 10, plus 1 is 11. 3 11's, 33. Find gf of 9. So this means we're going to find f of 9 first, and then that answer is going to go into g. So f of 9 is our first step. So f of 9, that's putting 9 into our f function. 12 over square root 9. 12 over 3 is 4. Then we're going to put 4 into the g. So g of 4 is 3 times 2 4's plus 1. 2 4's are 8, plus 1 is 9. 3 9's, 27. And part C, so part B, that was called a composite function. That's when one function goes into another function. Part C, this is called an inverse function. This minus 1 means inverse. So find g minus 1 of 6. The inverse of g, if you put 6 into the inverse function, what do you get out? For an inverse function, the input becomes the output, and the output becomes the input. It switches around. So, and it's the opposite function. So we could say, so I could change g of x if I expanded this into 6x plus 3. So I could say my g function is times by 6 and then add on 3. So you get the input, you times it by 6, then you add on 3, and that gives you the output. So find g for the inverse function. If you put 6 in, that means you start at this side, then you take away 3 and divide by 6, and that will go back. Or alternatively, so if we did 6, take away 3 is 3, divided by 6 is a half. So it should be a half. So what we're looking for is the input that gives an output of 6. What does x have to be for the output to be 6? So alternatively, we could write our function, which is 3 times 2x plus 1, equals 6, and solve for x. What does x have to be for the output to be 6? So we can divide both sides by 3, take away 1, and then half. So x is 0.5. X is a half. Okay, one for you to try. So give this one a go. Part A, find g of 3. So we're substituting 3 into our g function. Change the x into 3. So g of 3 is 4 times 3 3's plus 2. 3 3's are 9, plus 2 is 11. 4 11's, 44. gf of 16, so it's a composite function. Put f into 16 first, f into 16 first, so f of 16 is 20 over square root 16, which is 20 over 4, which is 5. And then 5 into g, so g of 5 is 4 times 3 5's plus 2. 3 5's are 15, plus 2 is 17. 4 17's, so double it and double it again. Double 17, 34. Double 34, 68. And find g minus 1 of 2. So the inverse, you're putting 2 into the inverse function for g. So what does x have to be to get an output of 2? 2 is the output. What is the input? So I can write 4 times 3x plus 2 equals 2, and find out what x has to be to give me an answer of 2. So I can expand the brackets, so 12x plus 8 equals 2. Take away 8 from both sides. 12x is negative 6. And then divide both sides by 12. Negative 6 twelfths, or minus 0.5. So if you put minus 0.5 in, you get 2 out. So if you go backwards, you put 2 in, you get minus 0.5 out. Question 16. The graph of y equals f of x is shown on the grid below, and we need to sketch f of x minus 2. So if the change is inside the bracket, it changes the x coordinates, and it does the opposite to what you think. So it says take away 2. That means you add 2 to the x coordinates. If it was f of x plus 3, you'd take 3 away from the x coordinates. The other change you could get is you could get f of x and then outside the bracket plus 2, and that changes the y coordinates and it adds 2 to them. So this is add 2 to the y coordinates. But that's not this question. We want to add 2 to the x's. So it's going to go 1, 2 spaces to the right, 2 to the right, 2 to the right, and so on. So our graph will become this one. So 2 spaces to the right. And part B, on the grid, graph A has been reflected to give graph B. The equation of A is y equals g of x. Write down the equation for B. So it's been reflected over the y-axis. So all the positive x coordinates. So there's not really a nice coordinate here. So this point had 3.53. It's now minus 3.53. So all the x coordinates have been multiplied by minus 1. So the changes to the x, that means it's inside the bracket, and it's just g of minus x. Okay, this one's for you to try, so give it a go. So for the first one, we want f of x plus 2. So it's plus 2 inside the brackets. So it changes the x and it does the opposite to what you think. You take 2 away from the x coordinates. So this is 2 spaces to the left. Part B, we've got graph A has been reflected to give graph B. The equation of A is g of x. Write down the equation of B. So it's been reflected in the x-axis this time. So our positive y's, so this point had a y coordinate of 1. It's now negative 1. This point with 2 is now negative 2. So all the y coordinates have been multiplied by negative 1. So the changes to the y, it goes outside. So it's minus g of x. Question 17. The point P has coordinates 3, 4. Q has coordinates AB. And a line perpendicular to PQ has the equation 3x plus 2y equals 7. And we need to find an expression for B in terms of A. So it's going to be B equals. We can find the gradient by using this perpendicular line. So if I make y the subject of this, I can get it into the form y equals mx plus c. So I'm going to take 3x away from both sides. So 2y is minus 3x plus 7. And then half every term. So minus 3 over 2x plus 7 over 2. So the gradient, so in the form y equals mx plus c, m is the gradient, and c is the y-intercept. So the perpendicular line has got a gradient of minus 3 over 2. To find the gradients of perpendicular lines, we do the negative reciprocal, flip a minus. So the perpendicular gradient it's going to go from a minus to a plus, and I'm going to flip it over, so 2/3. A gradient and a perpendicular gradient always multiply to make -1. you do flip and minus, the negative reciprocal. So the gradient is going to be 2/3. And we can also say that the gradient is the change in the y's divided by the change in the x's. And I can label these points x1, y1, x2, y2, and substitute them in. So the gradient is 2/3, and that's given by b minus 4 over a minus 3. So now I've got something with b's and a's in it, and I need to rearrange it to get b equals, make b the subject. I'm going to get rid of these fractions. I'm going to times both sides by 3 and times both sides by a minus 3. So 2 times a minus 3 is 3 times b minus 4. Expanding the brackets, 2a minus 6 is 3b minus 12. I want b by itself, so plus 12 to both sides. 2a plus 6 is 3b, and to get b by itself, just divide both sides by 3. Okay, one for you to try. Pause the video and give it a go. So again, we're given the equation of a perpendicular line, which means we can work out the gradient of our line. So to do that, we're going to get it into the form y equals mx plus c. So I've got 2x minus 3y equals 10. I'm going to plus 3y to both sides, because I want y to be positive. So 2x equals 3y plus 10. Take away 10 from both sides, and then divide every term by 3. So I've got 2/3 x minus 10/3 equals y. So it's in the form y equals mx plus c. It's got a gradient of 2/3. So the perpendicular gradient is a negative reciprocal minus 3/2. I've got x1, y1, x2, y2, and the gradient is the change in the y's divided by the change in the x's. So minus 3/2 is equal to b minus 2 over a minus 5. So times both sides by 2 and times both sides by a minus 5. Just get rid of the fractions. So we get negative 3 times a minus 5 equals 2 times b minus 2. Expand the brackets. So negative 3a plus 15, a negative times a negative is positive, equals 2b minus 4. We want b by itself, so plus 4 to both sides, and divide by 2. So b is minus 3a plus 19 over 2. Question 18. X is proportional to the square root of y, where y is bigger than 0. Y is increased by 44%. Work out the percentage increase in x. So if we've got a proportional relationship, that means x is equal to something times the square root of y. We could also get an inverse proportion question. That's not this one, but we could get one in the exam. And that will be x, if it's inversely proportional, it'll be k divided by square root y. So x is equal to k times square root y, and we're going to increase y by 44%. To increase by 44%, so if you've got 1y and you increased it by 44%, you will times by 1.44. That's our percentage, that's our multiplier. So our new x is k times the square root of 1.44 y's. So I've increased it by 44%, and to do that I've multiplied it by 1.44. Then I'm going to split this square root into square root 1.44 times square root y. Square root 1.44. So the square root of 144 is 12. The square root of 144 is 12. So that means the square root of 1.44 is 1.2. So I've got 1.2 k root y. Now k root y was my original x. So I can say my new x is 1.2 times my original x. So what is the percentage increase? If it's been multiplied by 1.2, what's the percentage increase? It's increased by 20%. Okay, one for you to try, so give this one a go. We've got the same thing, so x is proportional to square root y. That means x is something times square root y. We've increased y by 21%, which means times by 1.21. So our new x is k times the square root of 1.21 y's. I can split this up. So I've got square root 1.21 times square root y. The square root of 121 is 11. So the square root of 1.21 is 1.1. So I've got 1.1 times k root y as my new x. K root y was my old x. So my new x is 1.1 times my old x. If you times by 1.1, that means you've added on 10%. Question 19. Given that x squared minus 6x plus 1 is x minus a squared minus b, so that's completing the square. In completing the square format, we need to find the value of a and b. So this question says complete the square. So to do that, we half this middle number, half our b. Negative 6 halved is negative 3. Take away that number squared. So 3 squared is 9. We're going to take away 9 and then plus 1. So this, if I expanded it and simplified, is the same as this. So if I expanded x minus 3 squared, so x minus 3 times x minus 3 is x squared minus 3x plus 9, which is x squared minus 6x plus 9. So this is x squared minus 6x plus 9. Then I minus 9 plus 1 will give me 1. So it will give me x squared minus 6x plus 1. They're identical. I just need to simplify this though. Minus 9 plus 1 is minus 8. So that is the answer. Well, the value of a is 3 and the value of b is 8. So that is the answer. Hence, write down the coordinates of the turning point of the graph. So we can use the completing the square, that format, to give us the turning point. So we look at what makes the bracket equal to 0. That is 3. So the turning point is when x is 3. And when x is equal to 3, what's left? So 3 minus 3 is 0. 0 squared is 0. Minus 8 is minus 8. So we've got 3, negative 8. One for you to try. So again, we're completing the square. So I'm going to half the middle number. So half of negative 8 is negative 4. So I want x minus 4 squared. I'm going to take away the 4 squared. And then I've got plus 5 on the end. So I've got x minus 4 squared minus 11. So a is 4 and b is 11. Hence, write down the coordinates of the turning point. What makes the bracket 0? That's 4. If the bracket's worth 0, what's left? Minus 11. Question 20. DEF is a triangle. P is the midpoint of F to D. Q is the midpoint of D to E. F to D is called A. F to E is called B. So this is B. Because P is a midpoint, that means it's halfway. So all of F to D is an A. So I'm going to call these half of A each. Use a vector method to prove that P to Q, this line is parallel to F to E. So I need to work out what P to Q is. To do that, I'm going to work out D to E first. So D to E, I can't go straight down because I don't know what it's called. So if I go backwards to F and then along to E. So D to E is the same as D to F and then F to E. D to F is called minus A. So F to D is A, D to F is minus A, and then F to E is a B. So D to E is minus A plus B. D to Q is going to be half of that. So D to Q is just half of D to E. So it's minus a half A plus a half B. And then I can work out what P to Q is, because I can go P to D and then D to Q. So P to Q is P to D and then D to Q, which is a half of an A minus a half A plus a half B. Half an A, take away half an A is nothing, so it's just half of a B. So P to Q is half of a B, F to E is B, so P to Q is half of F to E. Therefore, they are parallel. One's a multiple of the other one. If one's a multiple of the other one, that means they must be going in the same direction. Okay, one for you to try. So pause the video and give it a go. This time we've got a parallelogram, CDEF. M is the midpoint of C to E, and C to D is called A. C to F is called B. And because we've got a parallelogram, parallelograms have opposite sides are equal. So this is also a B, and this is also an A. We need to prove that M is the midpoint of the line D to F. So we've got the line D to F, and we need to prove that m is the midpoint. So I'm going to work out d to m. If I work out d to m and d to f, d to m and d to f, and d to m should be halfway, should be half of it. D to m should equal half of d to f. So let's work out d to m. Well, let's do d to f first because it's easier. So d to f is just d to c and then c to f. So down there and along there, which is minus a plus b. So there's d to f, that's done. Now d to m. So if I work out c to e first, then half it for c to m, then I can go from d to m. So c to e is a plus b, which means c to m is half of that, half of an a plus half of a b. Now I can work out d to m because it's d to c and then c to m. D to c is called minus a, and then c to m is a half a plus a half b. Minus a plus half of an a is minus half an a, and here we have, so we've got d to f is minus a plus b, d to m is minus a half a plus half of a b, which means d to m is half of d to f. Therefore, it is the midpoint. M is the midpoint. D to m is halfway of the journey from D to F. Question 21. Solve 1 over 2x minus 1 plus 3 over x minus 1 equals 1, and give your answer in the form p plus or minus square root q over 2, where p and q are integers. So we have, let's add the fractions first. To add fractions, we need to make the denominators the same. So I'm going to times top and bottom of my left fraction by x minus 1, and the top and bottom of my right fraction by 2x minus 1. So we're going to have x minus 1. 1 times x minus 1 is just x minus 1 over 2x minus 1 times x minus 1. And we're timesing the right fraction by 2x minus 1, top and bottom. And that equals 1. Now we've got the denominators the same, we can make it into one fraction. So we're going to have 1 fraction over 2x minus 1 times x minus 1. So we've got x minus 1 plus 3 times 2x minus 1 equals 1. Now I want to get rid of the fraction, so I'm going to multiply both sides by that denominator. So I've got x minus 1. I'll expand the bracket now as well. 3 times 2x is 6x. 3 negative 1s and negative 3. And that equals 2x minus 1 times x minus 1. So on the left, I've got 7x minus 4. And expanding the bracket on the right, 2x times x, 2x squared. 2x times negative 1 minus 2x. Minus 1 times x is minus x. And a negative times a negative is positive. 1 is 1. So 7x minus 4 is 2x squared minus 3x plus 1. So we've got a quadratic. To solve a quadratic, we need to make it equal to 0. So I'm going to take 7x away from both sides and add 4 to both sides. So I've got 2x squared minus 10x plus 5. It's equal to 0, so I can now solve it. Now bear in mind the question said, give your answer in this form. So my only options to solve it are completing the square or the quadratic formula. They're the only options I've got. I'm going to use the quadratic formula with a is 2, b is negative 10, and c is 5. And the quadratic formula says x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So I've got minus 10 plus or minus the square root of negative 10 squared minus 4 times 2 times 5 all over 2a's, which are 2 2's. So simplifying this, minus 10 is just 10, plus or minus the square root. 10 squared is 100, so it's 100. Take away 4 times 2 times 5. 4 times 2 is 8. 8 5s are 40. Over 4, which is 10, plus or minus square root 60 over 4. I need to simplify this further because it needs to be over 2. So square root 60 has to have a square number inside it, and it's got a 4 inside it. So square root 60 is square root 4 times square root 15, which is 2 root 15s. So 10 plus or minus 2 root 15s over 4. And then I can halve everything, which will give me 5 plus or minus square root 15 over 2. And that is the answer. And one for you to try. So give it a go. Okay, step 1, add the fractions together. So we're going to make the denominators the same. So I'm going to times the left fraction by x plus 1. And I'm going to times the right fraction by 2x minus 1. I can now make it into one fraction. All over 2x minus 1 times x plus 1. I want to get rid of the fraction, so I'm going to multiply both sides by the denominator. So I've got 3 times x plus 1 plus 2 times 2x minus 1 equals 2x minus 1 times x plus 1. I need to expand all of these brackets. So that gives me 3x plus 3 plus 4x minus 2 equals 2x squared plus 2x minus x minus 1. Collecting the like terms, 7x plus 1 equals 2x squared plus x minus 1. It's a quadratic. To solve it, I need to make it equal to 0. I'm going to bring everything over to the right side because that will give me my positive x squared term. So 2x squared, take away 7x from both sides, minus 6x, take away 1 from both sides, minus 2. There is something I can do to this one to make it easier, and I can half every term. Divide everything by 2. So I've got x squared minus 3x minus 1. So I can use the quadratic formula with a equals 1. I've got 1x squared, b is negative 3, and c is negative 1. So the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a's. So I've got minus 3 plus or minus the square root of minus 3 squared minus 4 times 1 times negative 1 all over 2 1's. So minus 3 is just 3. Negative 3 squared is 9. Negative 4 times 1 times negative 1 is plus 4 over 2. So it's 3 plus or minus the square root of 13 over 2.